Okay, let's get started. So, today, we're going to start with Quiz 8 review, and we'll try and get this online for you. So, number 1. So, given 3x squared plus 10x plus 3 over x squared plus x minus 6, we're going to find the following. First, let's find the vertical asymptotes. To find the vertical asymptotes and the wholes, that's where our denominator is 0, okay? So right off the bat, what I'd like to do is factor both the top and the bottom. So let's look at f of x, and let's factor. So the top, or the numerator, 3x, x, that's going to make my 3x squared. Multiples of 3 are 3 and 1, but to make a 10, I'm going to put the 1 here and the 3 here. I'm going to go plus and plus, okay? So I know that if I did my double smiley, these two make a 9x, and these two make a 1x. Together they add up to the 10x, okay? Let's factor the denominator. Alright, so then we're going to have an x plus 3 and an x minus 2, alright? Now, here's what I know. X cannot equal negative 3, and x cannot equal 2, alright? But one of the things I notice is that the x plus 3 is removable. Okay, when we mean removable, we can just say, okay, let's cancel that, cancel that. If it's removable, it is a whole. So we have a whole at the value x equals negative 3. So negative 3 something is going to be the whole. Alright? The 2, x equals 2, is not removable. We're stuck with that. So as x approaches 2, we're going to go to infinity or to negative infinity. So this is going to have to be the asymptote. So my asymptote is at x equals 2. Alright, so let's go back to the whole, because we've got a negative 3 something. To find its corresponding y value, now keep in mind it is a whole, but it has a place value. Somewhere on the graph you find the whole, so it has to have a y, x and a y value, okay? Even though it's a whole. So to get the whole, we take the negative 3 and we'll plug it into the simplified equation. So we had this 3x plus 1 over this x minus 2 after I canceled out the x plus 3's, and then I can take my negative 3 and plug it in. Alright, so plug my negative 3 in, plug my negative 3 in, and I'll get the corresponding y value of my whole. Alright, so I'll have a 3 times negative 3 plus 1 over negative 3 minus 2. Let's see, negative 9 plus 1, let's see, that's going to be a negative 8 over negative 5, which is a 1.6, right? 8 divided by 5, 1.6, okay? Okay, I'm going to circle that. There's my whole, all right? And there's my asymptote. I'm going to circle that, okay? Two things I know for sure. All right?
So,
yes?
The asymptote x equal to is the vertical one.
Right.
And the horizontal one, I found it with the whole.
We haven't done the horizontal one yet.
Okay, so what did I find? What's the
Right. I'm going to show you. Let's take a look at the graph. I didn't want to graph it yet, Ani, but you asked a really good question. So let's go 3x squared. So what is the whole, right? Plus
the coordinate of the whole.
Coordinate of the whole, yes.
Okay.
Do you want me to keep, I'll come back to this, okay? Divided by my x squared plus x, subtract 6. Yeah. So let's just take a look at it real quick, okay? Okay, my vertical asymptote makes sense, but if I go and try and plug in trace negative 3, you can see right here it does not have a corresponding y value, right? So where is it? It's if I go back and forth, here's negative 3 and about a 1.6. You see as if we're cruising around the hole, we get close to the hole, it's pretty close to 1.6, right? You see the y value of 1.6? If we tried to go exactly there to negative 3, it's nothing. So we know the coordinate of the hole is at negative 3, 1.6. Even though the hole is not there, it's a, minuscule little spot that you'd fall through, okay? Okay, let's look at the horizontal asymptotes now. So to do the horizontal, we're going to let x approach infinity for our horizontal asymptotes. So if we do that, we're going to gobble up. Okay, we're going to let x go to infinity. Well, 3 times, in a sense, infinity squared plus 10 times infinity plus 3 over my infinity squared plus my infinity minus 6. And since infinity is so big, what happens, we just gobble up. I mean, 3 gets gobbled up, 10 infinity gets gobbled up, negative 6 gets gobbled up, infinity gets gobbled up. So what you're really left with is 3 infinity squared divided by infinity squared. So we know that our horizontal asymptote has to be at y equals 3, okay? Circle that, because we're going to have to graph that, okay?
So, Mr. Davies, what did you write about x equals infinity?
So as x approaches infinity,
What is it? Is it jet?
yeah, it approaches, that's the infinity sign, right? Let, that's let.
Okay.
That's let x, sorry. So what happens now is we've got a couple of things we can graph. The zeros, we already know our zeros. In fact, we know our zeros because way up here, the zeros is where the numerator is 0. So let's set 0 equals to our 3x plus 1, and not really even our x plus 3. So, I mean, I could go 0 equals x plus 3, but we're going to throw that out. The reason we're going to throw that out is because we already know that that is our whole. So, don't even do that. That's our whole. So, to solve for this one, minus 1, divide by 3. We'll have our 0 at x equals negative 1/3. So we'll have an answer of negative 1/3, comma 0. Okay, how's that?
Wait, where did that power square? 3 epsilon, which is infinite square, and the 10.
Right, so I plugged those into the original equation. Let me slide that back down. So to get the horizontal, I plugged infinity in for x. Right, and then of course infinity is so big it gobbles up all the extra stuff, okay? All right, now,
So, last question. How can I know that x approaches infinity?
what's that?
How do I know that x approaches infinity?
Okay, when we take a look at the graph, to be as the graph goes this direction, it levels off, doesn't it? And as x goes this direction, it levels off. So as x gets bigger and bigger and bigger and bigger, it levels off more and more. So as x approaches infinity, the height of the graph approaches 3. That's what a horizontal asymptote does. It tells us what the graph is going to level off to as the x values gets bigger and bigger in both directions. Both, yes. But the horizontal asymptote goes both ways.
Okay,
Yeah, right? Okay. Okay, now, one more thing that we want to get before I graph it, and that's the last thing I want to find, is basically the Y-intercept. So if we want a Y-intercept, I'm going to let x equals 0, because that'll give us a Y-intercept, and that would give us a f of 0 would give us a 3 times 0 squared plus 10 times 0 plus 3 over 0 squared plus 0 minus 6, which turns out to be negative 1/2, okay? And I'm going to circle that, okay? Okay, I'm ready to graph it. I really am. So, luckily, you know, I'm smart. I used my calculator. I've got a pretty good idea what it looks like, right? So now I'm just going to put in the specifics that I just found. So, let's go ahead and put graphing right here and here. A couple important things we're going to put in for sure. We're going to put our horizontal and our vertical asymptotes in. So if I go back to my vertical asymptote of x equals 2, I'm going to slide that in. There's my vertical asymptote, right? X equals 2. My horizontal asymptote at y equals 3. I'm going to have a hole at negative 3 and about 1 and 1/6. So I'm going to have a hole right about there. So just draw a little hole. See, just draw my little hole right there. I'm going to have a x-intercept or a 0 at negative 1/3 0, so that's about there. That's okay. I'm going to have a y-intercept at 0, negative 1/2. That's right about there. And I'm just going to go ahead and draw it in. Of course, it's going to approach the asymptotes. Doesn't touch them. Like that. And then this part of the graph here. All right. Almost done. Domain of this darn thing. Let's talk about the domain. Am I going? How's my pacing? Okay? Okay. I'll slow down for a second, let you guys catch up, and then we'll talk about the domain, okay?
So what did you do on the last part?
I just graphed it. I put in my hole, and I put in my x and my y-intercepts, right? Put it graphed in my asymptotes, and then just fit the curve within those parameters. All right. Now finally, domain. X is going to equal all real numbers except two spots. X cannot equal negative 3 and x cannot equal 2. That's my domain. It's the two places that cause us to divide by 0. So x can be anything except for those two values. At negative 3 we have a hole, and at 2 we have an asymptote, okay?
So that is what minus 1/3 and 0.
Minus 1/3 is my x-intercept, and I got that by letting x equal 0. I did it right here. If x equals 0, I get... Oh, no, I'm sorry. Wrong one. That's my... Right, that's my y-intercept, and I got that from up here.
Oh, okay. Gotcha.
Okay, everybody good on question number 1? Okay, take it away.
For the
Right.
I don't have to rewrite all the things like I do for the y. It just need the 3x plus 1 and
Right.
the 3x plus 1.
That's all I did, yeah. See, I actually got it from here, from the factoring. I won't take this one because that's my hole, right?
Why don't you take the denominator?
Why don't I take this one? Or the denominator?
Yeah.
That's where it can't be. Those are my asymptotes and my, right? 0 on the top is 0. 0 on the bottom is bad. 0 on the top is good. 0. Okay, let's take a look at question number 2. You guys ready for 2? All right. We'll get the 2 big ones done, and it gets easy from there, okay? All right, number 2. All right, we have f of x is equal to a 2x squared minus the 3x minus 2 over an x plus 1. Okay, now, if you take a look at B, before we do anything, B talks about a slant asymptote, okay? I was not here to talk about that. We're going to talk about it a little bit more today. So before I do anything, let's look at it. Let's see what the heck this thing looks like. So go back into y equals clear. I'm going to go parentheses, and I'm going to go 2x squared minus 3x subtract 2 divided by parentheses x plus 1. Okay, let's graph it. Alright, we're missing some of it, so let me fix my window. I'll go down a little bit more. Let's go negative 20. Let's graph it. Ah, there we go. That's what I want to see. Now, what's going on is right about here.
Davies, can you get in the closet?
No, I don't know what's going on. Somebody's working on something. So right about here, I just drew it in. Do you see a line like an asymptote, right? And it's not a straight across. It's not vertical. It's a slant asymptote. Do you guys see that? I just drew it in. So that's technically a slant asymptote. So what we have to do is we have to figure out what that is also. That's no problem. That won't be hard. Honest, won't be hard. So first of all, let's though take a look at vertical asymptotes, all right? So part A, let's do my vertical. To do my vertical asymptotes, we're going to find out what x cannot be. So we can't divide by 0. Remember, don't divide by 0, otherwise it kicks your asymptote. So let's take our x plus 1 and set it equal to 0 because we don't want the denominator to be 0. So at x equals -1, we're in trouble. At x equals -1, we're going to divide by 0, and it becomes a vertical asymptote. Okay? All right. Actually, if I take a look at my graph again, hey, it kind of looks like we might have a vertical asymptote right there, right? That makes sense. Now the slant asymptote. To do the slant asymptote, we have to divide. We're going to have to divide x plus 1 into 2x squared minus 3x minus 2. Now, luckily for us, since it's just x plus 1, we can do synthetic division. Much easier, you agree?
Why do we have to divide?
Because when we divide, what happens is we're going to get a linear, we're going to find out what the vertical asymptote happens to be, okay? So let's do synthetic division instead, okay? So if I do synthetic division, I'll go -1 into 2, -3, -2, right? I will slide down my first term and I'll get a 2, multiply, I'll get a -2, I add and I get a -5, I multiply and I get a 5, if I add I get a 3. Okay, so what my answer is this. My answer is a y equals a 2x minus 5 plus a 3 over x plus 1. Okay, that's my answer for synthetic division. Okay, now as x approaches infinity, because that's your asymptote, right? As x approaches infinity, it's going to follow this line of 2x minus 5. Now, what about the remainder? Well, as x approaches infinity down here, this just becomes 0. It really does become 0, right? So, as x approaches infinity, you go off on this vertical asymptote, right?
Yeah, I mean, can I go there and say?
Well, you can try, yeah. I'm going to keep teaching. She must be doing something over there. So anyway, this is my vertical asymptote, okay? Or excuse me, my slant asymptote. You don't use the remainder, okay? Don't use the remainder. We only need the 2x minus 5. Okay? Alright, moving on. Yeah.
I have to do that?
Why do I need this slant? Why do I need this? Okay, I drew it in red, but do you see the red line that I drew?
Yeah.
The equation of this line is actually, it really is, 2x minus 5. This line right here, the equation of this line is 2x minus 5.
This is the other asymptote?
Yes, this is the other asymptote. What'd she say? Okay. Was it her class? I don't know. Alright. Thanks, Caleb. Okay, now, let's see what we can do. Another thing I need to do is if I can find my x and y intercepts. So let's look at our x intercepts and our y intercepts, okay? So let's do the y-intercepts first. Those are the easiest. Just let x equal 0. We end up with a 2 times 0 squared minus 3 times 0 minus 2, right? Over a 0 plus 1 becomes -2. Hopefully you guys see that. So we'll have an answer at 0, -2. Okay, to find the y-intercept, just let x equal 0. Okay, so to find my y-intercept, I let x equal 0. To find the x-intercepts, let's let y equal 0. Am I going too fast? I'll write this down and... Okay, one of the things I did on purpose is when I was looking at the x-intercepts, I didn't write the denominator, okay? I didn't write the x plus 1 because I don't really want that to be 0. I mean, 0 on the top is 0, 0 on the bottom is bad, so all I really care about is the numerator when I'm looking for x-intercepts. So this will factor, it really will, 2x, x. I'm going to go 1 and 2 here. I'm going to go a negative here and a positive here. Okay, so we can check it. I'm going to have a double smiley, -4, +1 makes a -3, right? So if I'm from x-intercepts, it looks like I'm going to have 2 of them. In fact, let me go back to my graph. Hey, does look like 2 different x-intercepts, doesn't it? Right there and there. So I'm going to go 0 equals 2x plus 1, and 0 equals x minus 2. One of the x-intercepts is -1/2, and the other is 2. All right? All right, I have plenty to graph this, plenty of information to graph this. So let me slide up. I'll try and put it right up here, okay? Am I moving it too fast?
Everything else you can slide. Full power 0. So you're left with 2 over 1.
All right, you ready for me to graph it?
So what is Davies? Why like epsilon equals 0? Oh, no, I got it.
Right, and these should actually be written as -1/2, 0, and 2, 0. That's really the best way to write these. Okay, you ready to graph it? What's that?
Right under, no, below.
Hey guys, shh.
Below. Below.
Below that?
No, yeah, just above.
Right there?
Above.
Above?
Yes.
Oh, I factored. I took the...
Oh, okay. I thought it was a gamma.
No.
Sorry.
That's okay. Let's graph this, huh? So if I want to graph all this, let's take a look at what I have, all right? Again, the cool part is that you have it on the calculator. That helps a lot. You guys agree? If you can see it on the calculator, it helps an awful lot. And let's see here. So a couple of things I'm going to put in. My asymptotes. So one of my asymptotes it is at x equals -1. So I'm going to put in my x equals -1 like that. So x equals -1. I'm going to put in my slant asymptote. My slant asymptote is y equals 2x minus 5, right? My slant asymptote. So we start at -5. 1, 2, 3, 4, 5. We're going to go up 2 over 1. We're just graphing a line up 2 over 1. Okay. So these asymptotes are just boundary lines. Okay. We're going to have, let's see, -1/2, 0 is one of the x-intercepts, so that's right about there. And 2, 0 is right about there, right? We know the graph from our calculator looks something like this, right? Scoops down like that. And then we have a y-intercept of 0, -, oops, I kind of missed that one. I missed that one. Well, that's all right. Let me put a little, should put that one in. That would have helped me. There we go. That's better. And then the other one just folds right in like this, and then you get the graph, okay? All right. So just take your time tomorrow, right? These are all doable. All right. Make sure you have a good note card. All right. If you didn't have a note card, it'd be a little harder, but you know, just take your time. Make a good note card, and you're ready to go. Okay? Yeah.
We're not so inclined to domain, but the slant is y is not equal to. How do you write that?
Oh, the domain is all real numbers. In this one, the slant doesn't matter.
You just do the ones that are active.
Right, right. In fact,
But when you did the one above,
so you, right. So the one above, you're just looking for the 0 and the asymptote, right? Okay, domain real quick, almost done. Caitlin just asked about that. The only thing x cannot be is -1. So x is all real numbers except x cannot equal -1, okay, so for the domain. Does that make sense, Caitlin? That's the only x value we cannot have. In fact, if you look at the graph,
but when the slant asymptote crosses the x-axis, doesn't it have a point?
no, the slant asymptote is just a boundary line. It's not part of the graph. It's only a boundary line to infinity.
Why wouldn't it be x has to equal above -1?
X cannot equal -1.
No, why wouldn't it be it has to equal above -1? Because it doesn't pass over that asymptote.
So the slant asymptote is only critical at infinity. What happens in here? Right. The slant one, I know. So the slant asymptote, don't let this in here confuse you. It's what is happening at infinity, okay?
No, mind.
So the slant asymptote is going off to infinity. So what happens around the origin doesn't really concern the asymptote at all. It's just, we just draw it in. Okay, Brooke?
So the zeros are the y and x intercept.
The zeros are the x-intercepts. The zeros are the x-intercepts, okay? Caitlin, let's move on and I will help you individually, okay? Yeah, I'll go back and show my graph. Yeah, there's my graph, right? That's a hard one. There's no doubt about it. That is probably the hardest question you'll do. Okay, ready for number 3? All right, let's do number 3. Moving on. All right. So, number 3. Okay. I have x to the 4th plus 2x squared minus 8 is less than 0. Okay, now listen. First of all, there's no y values. There's no y values. There's no y values, so you're going to graph on a number line. You're going to do a number line. There's no y values at all, so we're going to do it on a number line, okay? We are looking for what values of x. If I plug in values of x, plug in, what values of x will make this whole thing be less than 0? So first of all, what I like to do is find my boundary points. My boundary points are where it equals 0. So I think this will factor. I believe it will. X squared. We're going to probably go 4 and 2 plus 4, negative 2, right? And I'm just going to set it equal to 0 for right now so I can find out exactly where my boundary points are. All right, so if I have an x squared plus 4 equals 0 and an x squared minus 2 equals 0, right? And I'm just looking for boundary points. I'm going to find out where it equals 0. Yep, I heard x squared equals negative 4. I heard imaginary number, which is right. You're going to get x equals plus or minus 2i, but we don't graph imaginary numbers on a number line. You don't. Number lines are for real numbers. Number lines are not for imaginary numbers, so we just throw that one away. We don't care about that one, right? We don't care about it. We do not graph imaginary numbers on a number line. Number lines are for real numbers, okay? So then, over here, we've got an x squared equals 2. Two answers, x equals plus or minus the square root of 2, okay? So let's see. Okay, I'm going to have a 1, 2, negative 1, negative 2. All right, square root of 2 is about a 1.4. It's about here. I'm going to put an open circle. And negative square root of 2 is about a negative 1.4. I'm going to put an open circle here. Open circle because there's no equal sign there, right? Now, I believe the easiest way to do this one really is to graph it. Even though it's not really it's a number line, I think the easiest way to do this thing is really by graphing it. I'm trying to show you every trick I can. X to the 4th plus 2x squared, subtract 8, graph it. So we're really looking for where the graph is less than 0. And that's not too bad because everything below the x-axis is where it's negative, right? So this is the region we want. We want all of the values in between negative square root of 2 and square root of 2. So we're just going to shade that region only. So I'm going to go back up here. And I'm going to go ahead and shade this region. So my number line, it looks like that. Okay. And then the interval, as far as interval notation, almost done. So interval notation, we're just going to go parentheses because it doesn't include it. Negative square root of 2, comma, square root of 2. If you like set notation, I'll take either one. Set notation would be negative square